Hello. In this video, I'm going to show you how to write a Python code that solves simple frame structure. I have taken this frame and analyzed. The output of this program will be rotation of two roller supports. Let me show you the degree of freedom of the joints of this structure. Here you can see, there are 9 degrees of freedom, but, along 1, 2, 3, 6 and 8 direction, the deformations will be 0. Since load applied is in vertical direction, deformation along 4 and 7 will also be 0. So our code will only display deformation along 6 and 9 directions, which of course are rotation of first and second roller supports respectively. This explains the boundary conditions of this structure. We will provide these conditions in our code. Now let's go to Python text editor. I am using PyCharm Community Edition. We need 2 Python libraries for this program. Let's import NumPy library and CalFEM library. Next step is to define element topology. An array E, D, O, F is defined and 2 array are assigned for 2 beam element. First row of this array is the topology of first beam element. As you can see in this picture, 1, 2, 3, 4, 5, and 6 are the directions of degree of freedom of first beam element. Second row is the topology of second beam element, whose directions are 4, 5, 6, 7, 8, 9. As there are 9 degrees of freedom, the stiffness matrix is of size 9 by 9 and force matrix is a column vector of size 9 by 1. 2 null matrices of size 9 by 9 and 9 by 1 are defined. Now, external loads are assigned. There is no external load in first beam element. There is a uniformly distributed load in second beam element. Equivalent fixed end forces and moments are calculated for this uniformly distributed load. Along 5 and 8 direction, vertical forces are assigned and along 6 and 9 direction, moments are assigned. But in code, forces and moments are assigned to 4, 5, 7 and 8. This is because, index of array starts with 0 rather than 1. Next step is to provide modulus of elasticity. Modulus of elasticity of steel is provided. Then assign area and moment of inertia of section. For this example, area and moment of inertia are taken as 0.105 and 1.072 times 10 to the power minus 3 for both beam elements. Then, assign these properties of beam element into in single variable for both beams. We shall define start point and end point of each beam element in local axis, both in x and y direction. Along x direction, for first beam element, start point is 0 meter and end point is 5 meters, and for second beam element, start point is 0 meter and end point is 10 meters. Along y direction, for both beam element, start and end point are both 0. Now local stiffness matrix for each beam element is obtained. For this, beam2e function available in Python library CalFEM is called. Then, both local stiffness matrices are assembled to global stiffness matrix, by calling awsm function from library CalFEM. The variable k global is the 9 by 9 stiffness matrix. After this, boundary conditions are defined as an array. Here, there is no deformation along directions 1, 2, 3, 5 and 8. This has also been explained earlier in this video. Then the equation stiffness matrix times displacement matrix equals to force matrix, k times u equals to f, is solved by calling solveq function from CalFEM library. Solving this equation, we get displacement, a, and reaction, r. Now is the time to print displacement and reaction for required directions. Reactions are printed for directions 2, 3, 5, and 8. Displacements, in this case, rotations, are printed along 6 and 9 directions. Thank you for watching this video. If you have any queries, please drop a comment. I will be back with another video on how to write Python code to solve 2D frame structure. So if you do not want to miss it, click the subscribe button.